So now I'm going to talk about a topic which is widely useful irrespective of what domain you are working. So that's about the difference between a public IP and a private IP. So let's begin with the public IP. So a public IP can be routed on the internet, thus hosts that must be internet accessible must be configured with or rechargeable by. So public addresses allocation of public addresses is governed by the internet assigned numbers of authority, that's IANA. And we have a private IP. So private IP is intended for internal use within a home or organization and can be freely used by anyone. However, private addresses can never be routed on the internet. In fact, internet routers are configured to immediately drop traffic with private addresses. Let's see some of the private addresses range that were defined. So there are three types of private address ranges were defined in RFC 1918, one for each IP version 4 class based on the IP version 4 classes. So let's begin with the class A. So class A address range begins with 10.10.0.0.0 to 10.255.255.255, whereas the class B address range begins with 172.16.0.0 to 172.31.255.255, and finally class C private address range begins with 192.168.0.0 to 192.168.255.255. So it is also possible to translate between the private and public addresses or private and public IPs using network address translation. So what it does, NAT allows a host configured with a private address to be stamped with a public address, thus allowing the host to communicate across the internet. It's also possible to translate multiple privately addressed hosts to a single public address, which conserves the public address space. So let me take you through the practical run. So then it would be much clearer. So here you can see it's related to the virtual private cloud. In this virtual private cloud, we have NAT gateways. So I have clicked on this NAT gateways. If you see the NAT gateways, at this moment there is no NAT gateways. What is a NAT gateway? A NAT gateway is the one which actually translate between private and public IPs. So NAT is network address translation. So let me create a NAT and see what's going to happen. If you use this service, you have to give the name and then subnet that you are using. So we have three subnets in Mumbai region. I will select any of the subnet and here I'll give my NAT gateway or my whatever it may be. So then what type of connectivity you want, whether it is public or private, you can go with the public so that everybody can access, and here you have to allocate elastic IP, and then finally you can add tags and you can create NAT gateways. This is how a NAT gateway works. Normally NAT provides an additional benefit. What is that? Hiding the specific addresses and addressing structure of the internal or private network. So NAT is only a temporary solution to address a shortage problem. So IP version 4 will eventually be replaced with IP version 6, which supports a vast address space. When that comes, you don't need to use this NAT anymore, because as we have discussed earlier, NAT has sorry, IP version 4 has some limitation in giving the IP internet protocol addresses. So that is the reason to overcome this. We are using NAT, so network address translation. So whereas once we completely move or switch over to IP version 6, IPv6, this problem will be solved, and we don't need to use anymore. We don't need to use NAT anymore. So that's the reason NAT is only a temporary solution. So now let's look into some of the reserved IP version 4 addresses. So the first one is the 0.0.0.0 forward slash 0 network is used to identify all networks. You can see mainly in AWS and those kind of Google cloud platform. So there you will find these kind of addresses. When you see this, what does it say is, it says it referred to the default route. That's it, nothing else. It referred to the default route. It identifies all networks. And there is one more type, that's 0.0.0.0 forward slash 8 range. Forward slash 8 means obviously the first octet only defines a network. So this range is used to identify hosts on the local network. That when you basically see on your laptop, when you try to host some application in your personal machine, or when you run a HTML file in your personal laptop. At that time, the local network, the local IP address would be like this. All are zeros and the forward slash 8. So then the third, the entire 127 x forward slash 8 range is reserved for diagnostic purposes. So the most commonly used address in this range is 127.0.0.1. Then the third one we have is the 169.254.x.x forward slash 16 range. So obviously the 16 is our CADR. That means the first two octets they represent network, and last two octets represent hosts. So this range is reserved for automatic private IP addressing, that is APIPA, automatic private IP addressing. And the fifth one is the 224.x.x.x to 213 on the 239.x.x.x ranges are reserved for multicast and are referred to as class D addresses. We have seen that in classes the class D addresses are multicast. And the 240.x.x.x to 255.x.x.x ranges are reserved for future and experimental use and were formerly referred to as class E addresses because they are not allowed to use, they are only for the future and experimental use. And the final one, the 255.255.255 address can be used as a broadcast address for the local network.